There it is, boys and girls. More shit you do in Queen Creek when you don't have a radius tool. Come on, you piece of shit. Focus. Actually, that's kind of half-assed. Fuck it. Good enough. Okay, well, that didn't work worth a fuck. Turns out the spline end of this is heat treated. And maybe the whole bar is, I don't know, but the treatment is definitely different. The hardness is different. Out here at the end, starting at about there where my thumbnail is, and so that tool steel cutter that I just radiused wouldn't even touch it. In fact, the carbide will barely get through it. So now I've got this big stress riser here, this this line on my graham cracker that says break here, and I guarantee it will break there eventually if I don't do something about it. In the absence of a proper radius, I can put an angle on here, and I want that angle to be as shallow as possible to help distribute the stress at the surface so it doesn't want to crack there. So I'm going to bring it all the way out to about here where the splines start. And we have two knowns right now. We have this dimension here on the x-axis, the dimension for the cross slide, which is 200 thousandths because the bar was 1 inch in diameter. We took it down to 6/10, so that's obviously 200 thou per side to get there. And then the distance from here, where we need to begin the cut, out to the end of the angle is 600 thousandths of an inch. So we have two knowns, and we have to figure out what angle to set the compound slide to. Now the good news is that it's relatively easy, and you don't even have to remember anything except Google. I'm sure you can remember Google. So I printed this out, and I made a note up here, and the note is SOHCAHTOA. And what that's for is a method of remembering what's described here in this image. So what it stands for is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So the idea there is that you'll remember that, you'll never fuck this up, and of course this was before Google. I can never remember it, I always just look it up, because it's Google. Anyway, here's what this does for us. If we have a few known quantities, we can determine the rest. And so if we have the distances, oh, actually, let me go back a bit. This is for right triangles. And a right triangle is a triangle that has one of the angles at 90 degrees. And so if we have a little bit of information, we can gather the rest based on these simple formulas and the sine, cosine, tangent function on a calculator. So what this is describing here is a method of determining distances based on the angle. So if we knew the adjacent and the opposite distance, the length there, and we knew the angle, we could use this formula to determine the length of that. But we're doing something different. We have these two lengths, we need to determine the angle. So the very first thing we have to do is define which parameters we do know. And in this case, we know the length of what's called the opposite. We know the length of what's called the adjacent. Back down here, the opposite is this distance, the 200 thou on the x-axis, and the adjacent is our 600 thou that we have to travel here. And of course, if you look at the formula assumes that you know the angle and you want to determine a length. That's not at all what we want to do. We know the lengths, we want to determine the angle. So what we're going to do is take the opposite divided by the adjacent, just like it shows here. And in this case, 0.2 divided by 0.6. Luckily, the math is easy. It's 0.33333, repeating, or 1/3. Now, instead of using the tangent function, we're going to use what's called the arctangent function. And you'll see it on your calculator as either ARCTAN, or occasionally, like on a Windows calculator, it will show up as tan to the power of -1. It's the reciprocal of the tangent. So don't let all these fancy words bother your auto mechanic brain, because it's very, very simple. Quite simply, we divide 0.6 into 0.2, we get 0.33333, right? So we punch that into the calculator, which I'll probably do and splice into this video. Then we simply hit arctan. And what we end up with is the angle that we need to set our compound slide to. And in this case, well, I did it already. I think it was 18.5 degrees. So I'll pause the video here. I'm going to splice in that section that shows you how to do the math so that you can see how simple it is. And because I don't want you focused on words that are confusing, tangent, arctangent, you know, the arctangent being the inverse of. I don't want you to worry about those things. I just want you to see how simple it is to punch in a couple of numbers into the calculator on your phone or on your computer and get that angle of 18.5 degrees in, you know, less than a minute and be done and go on with your work. And the last thing I want to do is mention to Andy Frost that I'm eating delicious, delicious, delicious beef jerky. Doesn't that look wonderful, Andy? While you're there sipping tea, I'm eating dead animal. And while I'm on that subject, I want to give a big shout out to Shane, my buddy Shane Tecklenburg. And when I say shout out, what I really mean is go fuck yourself. Delicious. All right, infidels, here's the next step. When you bring up your calculator in Windows, you have several options here. All different kinds of cool things. So you want to set this to scientific, and you'll notice that a few extra goodies popped up here, sine and cosine, and of course the problem is there's no, and tangent, of course, which is the one we're going to use, except that I said we're going to use the arctangent, and it's not here. So, because Bill Gates is a douche, or at least someone working for him is a douche, we find that if we expand this, oh, look at that. There were a bunch of fucking buttons that were hidden that no one told us about. Anyway, there is the the inverse of the tangent, which I told you about, sometimes called, or will show up as ARCTAN, sometimes TAN to the power of -1. You get it, I hope. So we take 0.2 divided by 0.4, we get 1/3. What the fuck did I do there? 0.2 divided by, there we go, don't even know how to use a calculator, 0.6, I think that's what I fucked up, whatever, 0.33333, on and on and on and on and on and on forever. We hit the button here for arctan, or the inverse of tangent, and we get an angle, 18.43 degrees. So we set the compound slide to 18.5 degrees, cut away, and the dimensions work out to exactly what we wanted them to be. It's so simple, even Shane could do it. Okay, so the angle is cut, but you can see there's two more problems. Hey, where the fuck did that come from? Well, I was trying to make the cut, hold the phone and video at the same time, so I created two new stress risers, and all I have to say to that is that you have to be tough when you're stupid. So time to get out some hand tools and clean that up, and also fuck Shane. Bye. All right, so there it is, blended in with some hand tools, and well, just basically all fucked up. Luckily it's mine, not a customer's, so we'll see if it breaks. Maybe I need video of that too. Maybe I should make a new show on the internet called Paul Fucking Things Up in His Garage, tipping over vehicles and breaking shit. So there it is. I'll get it installed. Let you know how it works. Alright, one more thing before I end this video. I did one the other night showing the ridiculous amounts of static friction in the bracket bushings on the Can-Am optional front sway bar, or anti-roll bar, that I installed last night. And so it's far worse when it's on the vehicle and the bushings are tightened down. You can roll the vehicle and it'll stay there. Roll it back the other way, it'll stay there. Move the motherfucker up and down. Look at that. It'll eventually settle. Or it'll just stay stuck down like that. Nice, huh?